Good afternoon. I'm Mr.Geoffrey from Obare High School, Mathematics Department. Today I'm going to take you through finding the matrix of transformation when we have two successive transformations. In our previous class, we saw how we could find successive transformations, that is the transformation that follows one after the other. Now today we want to find a single matrix of transformation that can result from the two or more successive transformations. Let us look at the case here. Find a single matrix of transformation for a successive transformation. From the previous example that we had done, and this was our example that we did last, we saw that triangle ABC was mapped onto triangle A prime, B prime, and C prime by a negative quarter turn about the origin. Then we also realized that after that, then we got the image of A double prime, B double prime, and C double prime, which was the image of triangle A prime, B prime, and C prime under reflection in the line y is equals to x. Now, to describe a single transformation that would map triangle ABC onto A double prime, B double prime, and C double prime, and find its matrix. Now, for us to find the matrix, we must first note that the matrix itself, when you look at the coordinate of A, B, C, and B double prime, A double prime, and C double prime, you will realize that this is a reflection. That is a reflection, and that's why we say the matrix is a reflection in the line x is equals to 0 or y-axis that maps A, B, C onto A prime, B prime, and C prime. That is when we are getting that single matrix transformation, that is when we are reflecting it. However, we can also find the matrix. How do we find the matrix? You say, let the matrix be A, B, C, D as the matrix of transformation. And since the matrix of transformation pre-multiplies the coordinate of the object to give us the image, then we'll allow the matrix A, B, C, D to pre-multiply the coordinates. And in this case, I've only used two corresponding coordinates, that is the coordinate of A and the coordinate of B. I've only used the two coordinates, that is the coordinate of A and the coordinate of B. Now, once we have used those two coordinates, then we realize that to get the image of A prime, then we'll say that we'll multiply, simple multiplication, A that times 1 times A, then 4 times B is equals to -1. We have A, that is A plus 4B is equals to 1. Then we'll also have A plus B is equals to -1. We'll have that. From this calculation, you will find that A is equals to 1, B is equals to 0. Then then we also want to get C and D. We'll have that is 1 times C, 4 times D. We will also have 1 times C, 1 times D, and that will give us C plus 4D is equals to 4, and C plus D is equals to 1. When you work it out, you'll find that C is equals to 0 and D is equals to 1. Rewrite these ones. We substitute for A in our matrix. A is -1, B is 0, C is 0, and D is 1. When we write them, we find that the single matrix that maps A, B, C onto A double prime, B double prime, C double prime is -1, 0, 0, 1 as the single matrix that maps that. However, there is another way you can get the single matrix apart from letting the matrix of transformation be A, B, C, and D. We can also say we get the two matrices that were used in the transformation earlier. For example, we used the first matrix of transformation is R, and our R was positive negative quarter turn, and our R was negative quarter turn about the origin. The matrix that represent a negative quarter turn about the origin, the matrix that represent a negative quarter turn about the origin is given there as 0, 1, -1, 0 as the matrix that represent negative quarter turn. Then this matrix is followed with another matrix V that is a reflection in the line y is equals to x, and the matrix that represents a reflection in the line y is equals to x is 0, 1, 1, 0. That is the matrix that represents a reflection in the line y is equals to x. Then we come and say that our first transformation was R, that was the negative quarter turn about the origin, and our last transformation we did was V, and V was a reflection in the line y is equals to x. With that order, the first transformation that we did was R, the second transformation we did was V. So in this case, the first transformation we used becomes the last, and the last transformation we used becomes the first. Therefore, to get that single matrix of transformation, we'll simply multiply VR, where R is the negative quarter turn about the origin, and V is the reflection in the line y is equals to x. Remember, we wanted the single matrix that would map A, B, C onto A double prime, B double prime, C double prime. And the two matrices are here. When we multiply these two matrices, then we end up with a single matrix of transformation, that is this 0 times 0 is 0, 0, 1 times -1 is 1, that is 1 times -1 is 1, that is -1 here. Then we'll also have 0 times 1 is 0, then this 0, -1 times 0 is 0, therefore we have 0. Then we also have 1 times 0 is 0, 0 times 1 is 0, and therefore that is 0. Then we'll have 1 times 1, which is 1, and 0 times 0, which is 0. 0 plus 1 is 0, 1. So we'll have the matrix of transformation as -1, 0, 0, 1 as the single matrix of transformation. So therefore note, we can get that single matrix by saying let the matrix of transformation be A, B, C, D, or we simply multiply the two individual matrices that were used in the transformation. But the order is that the last matrix you use in the transformation becomes the first. Remember, we did say that the order of matrices are very, very important. That is, in the matrix of transformation. Then under that, we're also going to look at the area scale factor of matrices. Then we realize that the area of image over area of object is equals to the determinant of the matrix of transformation. So the area of image over area of object is equals to the determinant of the matrix of transformation. That is, when we look at the example that is given there, we'll have in a transformation an object with an area of 5 centimeters square is mapped onto an image whose area is given as 30 square centimeters. Given that the matrix of transformation is x minus 4, 2, 4, find the value of x. The first case, we have the area of image, then we have the area of object. We can determine the determinant of this particular matrix, because determinant, we have said that area of image of area of object gives us the determinant of matrix of transformation. Therefore, the determinant of this particular matrix will be given by the area of image, which is 30, over area of object, which is what? 5. And therefore, the determinant is what? 6. So therefore, the determinant of this particular matrix is 6. Then how do we get the determinant? To get the determinant, we multiply the element in the major diagonal minus the product of element in the minor diagonal. So therefore, this is the major diagonal, this is the minor diagonal. So the product is, we'll have x times 4, which is 4x, minus, that is 2 times x minus 4, and that will give us 2 into x minus 4 is equals to 6, which is the determinant. So breaking the bracket, will have 4x minus 2x plus 8 is equals to 6. Therefore, 2x is equals to negative 2. And therefore, x is equals to negative 1. Therefore, the value of x there is negative 1. We have used the idea of area of image over area of object. Thank you, and have a nice holiday.